afternoon, good morning, depending on what part of the world you're joining us from. Welcome to the MEA Regional Event of the Digital Developer Conference, Data and AI. First of all, we'd like to invite you to the main conference as well, and you can access that by going to ibm.biz/devcon AI for more sessions right after this regional event. There are a lot of talks ready for you on demand, and you can access them at any time you like. So before we start, I'd also like to invite you to Call for Code. So what is Call for Code? It's basically using tech for good to address social and humanitarian issues. And why would you join Call for Code? First of all, it's for skill building, social good, putting your ideas to action, and you're going to be joining a community of 4,000 plus developers from 175 nations who've developed more than 15,000 applications. And the award for if you win the Call for Code is basically $200,000 for the Global Challenge winner, $10,000 for the University Challenge winner, and $5,000 for the Middle East and Africa region winner. My name is Fawaz Siddiqui, and I'm a developer advocate at IBM, and today I will be hosting this session. Just to add more onto the Call for Code, our this year's theme is towards clean water and sanitation, zero hunger, and responsible production and consumption. Just to get you started through this platform, on the top left, you will see the title for this workshop where you can interact and view more information about this event. On the top right, you will see the IBM developer where you can just follow us and to get notified about events. In case you have a question, you can ask us in the Ask a Question panel. We also have the workshop resources and the sign up to IBM Cloud link in the Get Started here, which is right under the screen. And in case you'd like to network with us or have anything to suggest, you can always chat with us in the chat panel on your bottom right. So this is the MEA regional event, and we would like to thank our partner, Open Source Community Africa, for really making this happen. We have around 5 sessions today. We will be starting with fraud prediction using automated machine learning, speed synthesis by using advanced machine learning techniques for easy readability of dyslexic children, building a recurrent neural network using TensorFlow and Keras, early forest fire detection via machine learning, brand-specific management, brand-specific AI-based target management with one of our ISVs. And also we have something new, which is networking sessions, where some of us will be sitting in a different session, which we'll guide you to. Based on your interest, you can join a session to learn more or network with us and get more experience towards this. So during the event, please do let us know how we are doing by filling up a really short survey. The survey link is ibm.biz/MEA-data-AI-survey, or you can even scan the barcode itself. One of my colleagues will be posting the survey link in the chat. So let's get started with our first session. And today we will be presenting predicting fraud using automated machine learning, and it'll be done by Khalil Faraj and Sibusiso Makombe. Guys, over to you.
Thank you, Fawaz. Hello, everyone. Just give me a second to share my screen and my camera. All right. Okay, hope you can see my screen. So hey, everyone. Thank you all for joining. My name is Khalil Faraj. I'm a developer advocate based in UAE. And with me, I have my colleague Sibusiso Makombe, who is a developer advocate based in South Africa. And today we'll be presenting the first session of this amazing conference that we're having today, which is basically the fraud non-prediction using automated machine learning. So to get started, please make sure to sign up on the IBM Cloud link, which is the MEA-data-AI. My colleague will be sharing this on the chat. We'll be using as well our own GitHub repository for the hands-on session that will be held by Sibusiso. And just like my colleague Fawaz was speaking earlier about the survey, at any time, feel free to just fill in case you want to drop. There are just a couple of questions that you can fill anonymously very quickly. So today's session, we will start first by talking about AI and machine learning, have some brief definition and compare them. Then we're going to tackle the machine learning process, because just like everything, machine learning has its own process and its own life cycle. And from there, we're going to talk about the 3 main types of machine learning. And then we're going to talk about the main challenges that we are facing these days, and how we can overcome these challenges by using a solution known as Auto AI, which is basically a subcategory of the auto machine learning field. And from there, we're going to discuss about the main Auto AI features and benefits, and we'll pass the stage to Sibu Siso, who will be doing our hands-on part. So AI, machine learning, deep learning, I'm sure all of us here have heard these terms, and all of us might confuse between these three big terms. And here, the main concept just to try to explain them and to compare them. And basically, AI is just having an intelligent system that has the ability to mimic and copy human behaviors. And to do that, we need machine learning. So basically, machine learning is a subset of AI that uses statistics to enable these machines to improve with experience. And deep learning is not in today's context, but we just want to put it there so you can have, so you can see how they can relate to AI and ML. And basically, the deep learning is a specific field by itself, and it's a subset of machine learning that enables computers to solve a bit more complex problem. So as we can see it, kind of we have the AI, which is at the top, then we have the machine learning, which is a subset of AI, and at the end we have the deep learning, which is a very specific field that is a subset of machine learning itself. So, of course, we want to talk here about the machine learning process because it has an endless life cycle. Basically, there are more main phases in machine learning. The first one is defining the problem and the solution. And this is maybe the most important part because we cannot build a machine if you don't know what we're trying to solve or what are our business use cases. So we need to make sure to first understand the business needs, define a scope, a minimum viable product, and then from there, when these are defined, we can go to the next stage, which is developing and prototyping the model. So here what will happen is the first step is to take the data, and this might be the most challenging part because we need to make sure that we are getting the right data for our use case, a data that has good quality, that's a bit balanced. So we want data that doesn't have some missing values or some outliers values and some extreme values that can affect the model. So this can take some time to find the right data for our use case. But once we have it, we will go ahead and prepare it. This is basically by changing some of the values in case we have some missing values or converting some of the types that we have. And from there, we will go ahead and train the models. And one of these models are trained, we will go ahead and evaluate them. And once the evaluation is done, we can go ahead and start to productionize the model and to deploy them. And from there, we can start making some predictions. This will eventually lead to our measurement phase, where we can monitor the prediction and gather and analyze the insights that we have. And as I said earlier, all of this is kind of an endless loop. It's an endless life cycle because we don't have a model that's defined and it's good to go. We always need to keep sure that we are maintaining this model, we are updating this model as well, because we will have a new data set each time. So in a lot of time, we will work with some new data set that we need to add on top of the current data that we have. And with that, we will need to re-evaluate the model and kind of fine-tune it a bit. So that's why it's an endless life cycle. Now, when we're talking about machine learning, we are talking about three main categories, which are supervised, unsupervised, and reinforcement learning. Now, the most common one and the basic one is the supervised learning. And in supervised, we're basically feeding the data by labeling it to our algorithm. So let's take this example where we want, for example, to build a classification model that can compare and differ cats from dogs. And in this case, when I want to feed this data to my algorithm, I'm going to tell him that this specific data set has dog images and this data set has cat images. So each time I'm labeling which image is a dog and which image has a cat. And so with time, the algorithm will be able to understand what a dog looks like and what a cat looks like, because I'm telling him that this is a dog and this is a cat. If you want to see it from a mathematical perspective, if you look on this graph, this is basically how it looks. We can imagine that the green dots are the cats and the blue dots are the dogs. And we can see that here they are being classified into two different areas. So this is kind of how the classification algorithm works. And we use classification for many, many cases: fraud detection, image classification, customer retention. And this is basically what we'll be using for our workshop today, which is the classification algorithm for a fraud prediction use case. And as well, another common algorithm in the supervised learning is regression, and it's used for forecasting, predictions, process optimization, and new insights. Now, the other category is the unsupervised learning. And this works by giving the data just as it is to our algorithm without labeling. So we won't be telling any information to our algorithm. Instead, the algorithm will start to find some patterns and relations that it can detect from the fields that we have in our data set. So another example that we can give here is a recommendation system. Let's say, for example, I watch horror movies on the weekend, and I watch comedy movies or action movies during the weekdays. Let's say comedy. So in this case, the algorithm will start to understand this pattern that every time I'm watching these horror movies on weekends, it will start recommend for me horror movies on the weekend. And because I'm watching comedy movies in the weekdays, it will start recommend me some comedy movies on the weekend days. So by understanding my pattern, by seeing these relationships and again this pattern, so basically it will be able to recommend me what I'm watching on which days. And this is basically a very basic example on how unsupervised learning works. So we have two main algorithms as well. The clustering, which covers the recommendation as an example, as I was saying before, the target marketing, customer segmentation. And the other type is basically the algorithm, is the dimensional reduction. And in here we work more with big data visualization, meaningful compression, structure discovery, and feature elicitation. Now, the last type is reinforcement learning, and we use this mainly when we're working with robotics or games. So reinforcement learning basically works on the rewarding system. So we should have three main elements, which are our agent, environment, and our action. We'll go ahead and take the example of a robot, which in this case will be our agent. So let's say we have a robot, our agent, in a room, which is our environment, and we have some actions, like, for example, we want a robot to move to the left, okay? Now, what will happen is, if the first time the robot moved right instead of moving left, then here he did the wrong move. So in this case, we're going to deduct points from him. So the next time he will run, he will understand that he shouldn't be moving to the right side, because he just lost some points. So in this case, now let's say he moved to the left, and here he did the right move. So we're going to give him points, and that's what we mean by rewarding points. So now the robot understands that he should be moving left because he just earned some points on that. And this is what reinforcement learning. So the agent will be able to understand what action he needs to be doing based on the concept of points, by either rewarding him or deducting points from him. So with that, we can move to the main challenges that we are facing these days. So the thing is that today we have a high demand for data analysts, scientists, and machine learning engineers, but we lack the skills to meet these demands. And even if we do have some skilled people, but using traditional machine learning techniques are very time consuming, and they do require a lot of effort. And that's because mainly we first need to prepare our data, and this by itself, it can be very time consuming because, as I was explaining earlier, we need to make sure that we have the right data set, and we need to go ahead and clean it to make sure that it's kind of balanced and not biased for a specific use case. And then even if we have our data prepared, but we need to go ahead and compare different algorithms to choose the best one for our use case. So deciding on the right algorithm is, again, another issue. And the other big challenge is when it comes to deploying and the strict resources that we have. Because imagine we are working with a huge data set. In this case, we should have a very powerful machine that will be able to process this huge data that we have. So this kind of can be a bit of a strict resource in this case. And again, we need to kind of find a way to deploy it. So all of this can bring a bit of a hassle to the traditional machine learning technique. And that's why we're going to talk about auto machine learning. And in this case, we'll be using one of its main services, Auto AI. Basically, with Auto AI, what we can do is simply upload the data in a CSV file, for example, just upload it. And the Auto AI service automatically will be preparing this data for us. So instead of having us to do all this work, Auto AI will be doing this. It has feature type detection. Let's go ahead and check the missing values. And it has as well feature encoding and scale. And the other thing is, it will select the model for us. So I was saying before that sometimes it's hard for us to choose the right algorithm, but in this case, Auto AI will go ahead and explore a wide range of estimators and will select the best estimator for the data for our specific use case. So in this case, we will not be doing anything. It will do the work for us. So it's kind of an AI for AI. The next phase basically is hyperbranch optimization and feature engineering. So these two kind of fine-tune the model that has been selected to be able to increase its accuracy and its predictions in a better way. So again, Auto AI will be doing all of this. And the last thing is, once we have our model set, we chose the best model that we have for our use case, we will go ahead, save, and deploy the model, and it should be good to go and to use it. So the main benefits here is we are building our model much faster. So we're not preparing the data. We're not spending time and choosing the right algorithm. So Auto AI is doing this for us. So this is the first thing, that we are building our model much more faster. The second big benefit here is we are jumping the skills gap. So Auto AI is done to be used by anyone. Either you have a technical background or a non-technical background. You don't need to be a machine learning expert to use Auto AI. It's literally for anyone because we are not using coding. So that's the great thing about it. And this is why it's very fast. So no coding, we'll just go ahead, put our data set, and AutoAI will go ahead, do the work for us. We can jump the skills gap. And because AutoAI explore all of these different algorithms that we have, so it can discover more use cases. It can embrace machine learning everywhere to disrupt and to transform. And it can find some signal from noise, and by that we mean auto feature engineering will make it much more easy for us to extract more predictive power from your data, because this is where we kind of can fine-tune our model to have a better prediction and a higher accuracy. And once we have all of this ready, AutoAI will be ranked these different models that we have. And basically, each model is known as a candidate pipeline. We will see this in a bit with Sibu. And it will rank us all these candidates, and every candidate represents a specific model. We will go ahead, and this is where we can choose the model that suits the best for our use case. And then we will just deploy it, and it will generate for us some REST APIs that we can use and integrate them, whether in our mobile app or in a web app or whatever app we're trying to build. So this is basically was a very brief kind of presentation on what AutoAI is and what are the kind of challenges that we're facing these days. And now let's go ahead to talk about the workshop that Sibu will be conducting. So the workshop is basically, we'll be covering a common banking use case for loan applications. So we'll see how we can prepare data and build predictive machine learning models for fraudulent loan application. So because, in banking, a lot of time, they will have people that will submit a loan application, but the bank is not sure whether this person will be able to pay the loan back or not. So in this case, we're trying to build this predictive model that will be able to see if this is a safe kind of customer, he will be able to pay back the loan, or that no, this is not a safe customer, he won't be able to pay the loan, so let's go ahead and reject him. So we'll be building these predictive models without any coding. So we'll be basically using AutoAI on Watson Studio, rebranded as Cloudpack for data for Ibm. And once we will prepare this data, we'll have different models that we're going to compare them, and then we'll go ahead, save, and deploy the best model on Ibm Cloud. So please make sure to sign up for your Ibm Cloud account if you haven't yet. And Sibu will be showing you how go a bit into this workshop and show you the GitHub repos that we will be using. So Sibu, this stage is all yours.
Okay, thank you so much, Khalil. I'm just going to go ahead and share my screen right now. Okay, good afternoon once more to everyone. Thank you so much for joining. My name is Busom Kombe, and I'll be taking everyone through our hands-on session for this part here. So what I will do is I'm just going to share one more time in the chat section. I'm going to share one more time the link to the hands-on session that we will be following along. And then when you open up this link here, it should take you to this GitHub repo, which contains the README file of the instructions that you need to follow along to sort of have a complete project. And it also has a few things in here. So firstly, there is the slides in which Khalil was sharing. So in case you have a need to access those later on, please feel free to download that. There's the Python notebook that you can actually download because as an alternative to using Watson Studio deployment, we can actually use our Python notebook to sort of deploy our models. Then there's the data set here, which is the CSV file, in which we'll be sort of training and testing our model on. Then the simple data.json, which is essentially the JSON file of our data. Okay, so as my colleague has actually mentioned here, is that what we're doing today is we'll be sort of predicting fraud loan transactions using automated machine learning. And what this will then do is it will allow us to sort of reduce any loss of money or mitigate risk in our businesses, right? For example. Then also as well, some of the objectives that we'll be sort of going through today is, first and foremost, we want to go ahead and set up our IBM Cloud services. Then from there, what we want to go ahead and do is we want to ingest the data, which is the CSV file that I've just mentioned previously, into our Watson Studio and then initiate the auto AI process. Moving forward from there, we'll then go ahead and build our different models as pipelines using our auto AI and then evaluate their performance. Then what we'll then do is we'll get to then have a chance to choose the best model and then complete our deployment. After all of this is done, we'll then get another chance to go ahead and test how our model is performing by generating predictions, which we will do using our deployed model by making REST API calls. Okay. With that being said, what I want to go on and talk about next now is our actual architectural diagram here. And what I will do is I'll just open this in a new tab. Okay, so that's taking a bit of time to load. That's fine. Okay, hopefully everyone can just see this clearly. Okay, that's fine. So the architecture of this sort of our application here is that what's going to happen is we're going to have to create a Watson Studio instance, as I've mentioned before. That's number one here. Then this will allow us sort of create a project in it where we will have our Watson Auto AI and Cloud Object Storage instance in it. And I will talk a bit into much more detail in the next few minutes with regards to the various services that we'll be using today. Then after we create our Watson Studio instance here, what we'll then do is we will then upload a CSV data file into our cloud object storage. So that's what number two does for us here. Then what we will then do is we will then kick off the model building process using Auto AI and create pipelines from this CSV file, as you can see, number 3 here. And then this links to number 4 with the Auto AI instance. And then we will then evaluate different pipelines from our Auto AI and select the best one. Then from there, generate predictions, as I've just mentioned before, with on number 5 and number 6. So this is how the architecture is set up for our instance here. Okay, then so going forward from here, what I will do is I'm just going to navigate all the way to IBM Cloud. So please just take a moment to then log into IBM Cloud if you have not already done so that you can actually follow along accordingly. Okay, so I think what I will do is I will then proceed now to talk about the various services. Okay, so what we want to provision first and foremost here is a service called Watson Studio. So you want to go ahead and just click on search resources here and then type Watson Studio in the search bar. Then you want to navigate all the way down under catalog results here and click at the Watson Studio instance. Okay, so what you want to go ahead and do now, as soon as this loads, that you want to go ahead and just create the instance. Then just ensure that you are using Dallas here right now. So you want to just navigate all the way down and just pick Dallas there. Then from there, you will just navigate all the way down, give your Watson Studio instance a name, or you can as well alternatively leave it as default. That's completely fine. Then from there, just click on create. So I've already done this here, so I will not create a new instance, but please just do so. It will take a bit of time to provision. That's fine. Then as soon as that is doing in the background, what you want to go ahead and do is I'm just going to open up a new tab of IBM Cloud, and I'm just going to walk through the next service that we will be using. Okay, so the next service that we'll be using is our machine learning service. So what the Watson Studio that we just provisioned does for us is it is actually the home of our machine learning, right? And allows us to sort of infuse AI into our innovation. But what we want to provision that is going to complement or supplement that rather is a machine learning service on IBM Cloud. So just go ahead and just search for machine learning here. Okay, so as soon as that the results come back, just go under catalog results and click under machine learning. Okay, then just again, just go ahead and pick Dallas as the location here. Then from there, you can just give it a name or leave it as it is, leave it as a default name, that's fine. Then click create. So what the service does for us is it allows for our developers and data scientists to sort of collaborate to integrate predictive capabilities later on into our actual applications. So please, you need to ensure that this is done accordingly for us to sort of proceed. Then lastly, what you want to provision next here is our actual cloud object storage. So please go ahead, search one more time for cloud, or rather just search for object storage. Okay, then under catalog results here, what you have here is the object storage instance. Just click on it. So what this is it is essentially a highly scalable storage service that allows us to sort of store our data, then later on be able to access and manage our data in an efficient manner. So please just go ahead and create a service here as well. Then you just want to give it a name one more time, pick a name that works for you, or leave it as default, whatever works your liking. Okay. So as soon as we are done with provisioning these three services here, and I'm just going to close these two tabs, what you want to go ahead and do is you want to go back to your Watson Studio service. So hopefully by now your service has completed its initiation. Then what you want to go ahead and do is go on to the home page. So I'm just going to open up one service that I've created before because I didn't create a new one. So I'll just open up a Watson Studio service. Okay, let's just try and refresh that. Okay, it seems to still be loading. That's weird. Okay, I'll just try refresh one more time. Okay, it seems to still be loading, so I'll just give it a few moments. Okay, so I think okay, what I will do is I'll just try and access it again from my home page. I'll just try and access it again. Okay, so that seems to have been solved. Okay, that's fine. So this here, as I've mentioned before, this is your home of machine learning, and this is the home page for that, right? But to actually get the development environment, what you want to go ahead and do is just go ahead and click on Get Started. So what this will do is it will open up a new tab with your Cloud Pack for Data AI instance running, where we'll be then be provisioning our Auto AI instance and creating a new sort of project from here. So as soon as you're on this page here, everything worked well so far. What you want to go ahead and do is you want to go ahead and create a new project. So to do that, what you just go ahead and click on create a project. So as soon as this loads, you want to create an empty project. Then, of course, please just go ahead and give your project a name. So I'm just going to maybe say for this project Auto AI, or I'll just say fraud prediction rather. Okay, so I'll just call it fraud prediction. Then you can go ahead and give your project a description. This is optional. Then very important, what you want to go ahead and do is link a storage instance. So because I have already provisioned or created my cloud object storage instance, it automatically appears here. So if it does not do that on your end, it means that you need to go ahead and create one. So there will be a button somewhere here which allows you to go ahead and do that from this page. Alternatively, you can just create a cloud object storage instance from IBM Cloud, like I showed you before. Okay, then what you will then go ahead and do next here is just click on create. Okay, so as soon as this is done here, you already have your project set up. What you want to go ahead and do next is you want to click on Add to Project. So what this will then do is it will give you an option of what you want to add to your project. And for this instance, I will just add an auto AI experiment. Okay, so just click on that. Okay, then we'll then need to give our auto AI experiment a name. I'll just say auto AI fraud. I'll give it a name like that. Then as soon as that is done, what you want to go ahead and do is give it a description. Please do so if you have a need to do that. Then as soon as we are done here, what you want to do is, remember earlier on I've mentioned that we will be associating our machine learning service to our Watson Studio. So how we do that is that we actually go ahead and click on associate a machine learning service instance. So if you click here, it's going to open up a new tab which has a list of all your provision saves on IBM Cloud. You want to scroll all the way down and just tick the box that has the machine learning instance in it. Then as soon as that is done, what you want to do is just click on associate service. Then what that will do is it will add the service that we've created before into our new auto AI experiment. Then if you click on reload, the service should appear now. As you can see, the name of the service is appearing accordingly. Then what you then do next is just click create. Okay, so now I think the environment is set up. We have created a Watson Studio service, created an auto AI experiment, associated both our machine learning service and our cloud object storage service, right? What you want to associate next with the project or then link or add here is an actual data source. So as I've mentioned before, what we'll be using for a data source here is we'll be using our CSV file, right? So if you navigate all the way back to the GitHub repo, you have a CSV file in which we can download here. So for us to do that, you'll then go ahead and just download the entire repo here. Firstly, so I'm just going to download this here. Okay, let me just go a bit down. I'll download it as a zip file. Okay, I'll just leave it in my desktop. Okay, then what I will then do is I'll just extract everything from here into a folder. Okay, so now in our desktop here under the folder fraud loan predictions, we have our actual data set in here, right? So the data set itself, before we associate it, what I want to do is I want to just talk a bit about how it looks. So if I go ahead and just click on the actual CSV file, you will see that we have this data set that has various attributes in it, right? So this is what our machine learning model essentially will be built on. So we have various attributes here, which will then contribute into sort of predicting whether or not a loan claim could be fraudulent in the future. So some of the attributes that we have here is we have the gender of the applicants, we have whether they're married or not. We have the number of dependency of dependents which depend on our applicant. We have whether they're educated or not. So the numbers here, in case it's 0 and 1, as you can see, where that represents false and true. Then we have an attribute here where we sort of see if our applicant is self-employed. We get our applicant income as well as an attribute. We get, if they're married, we get their spouse's applicant's income, then the loan amount in which they want to take, and the number of terms in which they'll be repaying the loan. Then we'll then have another attribute for credit history, if it's available or not. Then I will have the last 3 here, which is housing locality. And then this here will then all link to our last column, which will then be our prediction, whether it's a possible fraudulent risk or not. So as I've mentioned before, we have 0 and 1 representing false and true in this instance here. Then we want to link this data here into our actual project. So for us to do that, what we do is we just click on our browse here, and then we navigate all the way to our fraud dataset CSV. So if I just open this here, what it will do is we will then upload it into our project. Then from there, as soon as it is uploaded, what we want to go ahead and do is we want to select a column which we want to predict, right? So under here, what I will do is I will just navigate all the way down and click on fraud risk, which is our target column. So as soon as I've done that, we have an option now to go ahead and change a few settings of our experiment. But what I will do is I'll just go ahead and click on run experiment to see exactly what pipelines come from there. Okay, so while this is running here, what I will do is if you have any questions, please feel free to go ahead and ask in the chat section, and I will be addressing those accordingly. Okay, so I will just give this about a minute to see what pipelines get generated. Okay, so as you can see as well, it's showing the process that is currently undergoing here, and the time that it takes to actually go ahead and do this here will essentially depend on the size of your data set. So you might experience you might have to wait a bit longer for larger data sets as compared to smaller ones. Okay, so as you can see now, what's happening is we are generating pipelines here, and they are sort of being ranked accordingly. So let's just wait for those to sort of populate. So I'll give it an extra 30 seconds to a minute before proceeding. Okay, so I think while this is still generating, what I would like to talk next real quickly about is the various things that you actually see on your pipeline leaderboard here. So first and foremost, what happens is each of these pipelines, right, they run under different parameters. So when you go under enhancements here, as you can see, we have HPO and FE. What the HPO will then refer to is will refer to your hyperparameter optimization, and your FE will then be your featured engineering. So these are the various enhancements that have been used by our pipelines. Then what you will then see is the algorithm in which is being used. So you see here we have the extra tree classifier. So what that represents is our extremely randomized tree classifier, which is a sort of a learning a machine learning technique which allows us to combine the results of multiple correlated decision trees to sort of have a classification result as an overall output, right? Then another algorithm that we have here is the LGBM classifier, which essentially is the light GBM, which is a gradient-based boosting framework that uses a tree-based machine learning mainly, and has advantages like better accuracy, faster training speed, higher efficiency, and it's capable to handle large scale data. So this is what the algorithms will then represent here. Then I think now we can just go ahead and view our first ranked algorithm here, which is pipeline 3. If I go ahead and just click on it, what you will see here is you will see its name, which is pipeline 3. It's ranked first. you'll see its holdout accuracy under here. You will then see the algorithm which it used. You will then see the enhancement that I've just spoken about. Then, then you can just proceed to then have a look at the model information. It will tell you what column was predicted, the number of features, the number of evaluation instances. You can then go ahead and just look at the feature transformations, then feature importance as well, which is just our various categories are ranked accordingly. Then you can just go under model evaluation to see our ROC curve as well. Then you can just see the model evaluation measure as well as a table there. Then next you can sort of see next your confusion matrix. So this here is just a table that sort of shows how our model is performing. Essentially, so as you can see, every single time where there was a 1 and it predicted to be a 0, it sort of highlights it here, and vice versa here. So the number of instances that it predicted correctly was 43, where it predicted a 1 to be a 1 and a 0 to be a 0. And this is the overall percentage accuracy for our model as well. Then lastly, you can just go ahead and look at the precision recall curve, which essentially just shows the trade-off between our precision and our recall for various thresholds, right? Then this here, a high precision will then sort of correlate to a low false positive rate, and a high recall will then correlate to a low false negative rate. So this is how this would work here. So as soon as this is done, we are able to see, you're able to sort of view this for each of the various models. Please take a bit of time later on to then go ahead and do that. What we want to do next here is we want to actually go ahead and just sort of create our model. So for us to do that, what we do is we just come here in the blue button that says Save As. Then if I click it, we have an option to then save this as either a notebook. And as I've mentioned before, we have an option to do that. So just go ahead and have a look at that in our actual README file. So if you navigate all the way down, there should be instances of how to proceed using your Jupyter Notebook as well. Then for now, what I will do is I'll just save it as a model. I'll leave it as it is. I can just change the name here to P3. Then I'll just say maybe extra cheese classifier best model. Just in case this was the best model that I've received. Optionally here, you can go ahead and add a description. So please go ahead and do that. If you need to, then just click on create. Okay, so as soon as this is done, you can just click in view in project to see our model. Okay, so as you can see, this is our model here, and this is the column that it has, the type of variable that is associated with the column. Where we'll be able to deploy our model so that we can actually expose it as a web service API later on as well. So I just want to click promote deployment space. Okay, so what this will then do is it will lead you to this page here where you have the ability to then go ahead and create a new space for your model to sort of be promoted to. So you're going to go ahead and click on create a new deployment space. Then as soon as this loads, you want to go ahead and add a unique name for that, or a new name for that. I will just add no code demo. Then maybe for this instance here, let's just see, I'll just maybe use 3 just to differentiate it. Then what I will do is I'll just click create. So you can have a description for it. And as you can see here, there will then be a cloud object storage being associated. Then you can associate your machine learning service as well. Then just go ahead and click on create. Okay, so this will take a bit of time. So let's just give it a moment or so. Okay, so as you can see, this is created successfully. So we are all good to go. So what you want to go ahead and do now is you can actually just click, so just select it here, that's fine, and just click promote. Okay, so that was that happened successfully. That's fine. So we are now back into our default homepage for our project. So what you want to do next is, as you can see, we have our model stored under Auto AI Predict, stored as rather Auto AI for prediction P3 X justifier best model. Just go ahead and click on your model next. Okay, so now that we've sort of created a deployment space, you will then have an ability to then promote this model into the deployment space. So let's just see if that's possible. Then for us, we'll then select our target deployment space and we'll just try and promote it one more time. Okay, then if you go ahead and just click on it, let's just see. Okay, I'll just navigate all the way back. Okay, that's fine, that's fine. So I think let's just go ahead and have a look at what we get here. Okay, let's see. Okay, so I think what I will do now is just have a look at our deployments real quickly. Okay, then if I just have a look at the deployment space here, let's see if anything is associated in here. Okay, that's perfect. So as you can see here, what we have now is we have our model being associated with our deployment space here. So for us to then proceed here, what we want to go ahead and do is just click on this little sort of rocket icon here that says deploy. Then that will then just deploy our model, and then I will ask us if we want to deploy the model as whether as a online web service or as a batch process as well. So for this instance, just click on online, give it a deployment name. I'm just going to name it Auto AI Deploy. Then I'll just say 3. I'll just say 3 just to differentiate. Then I'll go ahead and just click on create. Okay, so as soon as that is done, we should get a notification for that. Let's just see. Okay, then what we can do is we can just navigate all the way back to our model. Then we can just try and test it out as a web service if everything worked accordingly. So I'll just navigate back to projects. Then under projects here, I will go to assets. Then I'll just have a look at my model. Okay. Okay, let's just have a quick look at our deployments once more. So it does take a bit of time sometimes. Okay, let's just have a look at this here. Okay, so it says deployed. Let's just have a look at it. Okay, that's perfect. So as soon as it is deployed here, as you can see, mine already is. So it might take a bit of time on your end at times. So what you have here is you have the direct link to the endpoint for your model. You also have the code snippets here of essentially how you can use it as an API essentially. So you have for curl, for Java, for JavaScript, for Python, and Scala as well. Then what we want to do now is want to go ahead and test our model. right? So this here is how we can test it using test it as a web service essentially. So what we'll do is we have to sort of put in data in here. So this is the data that we have from our previous CSV file. So if you remember from what I've discussed before, in our CSV file here, we have data in which our model trained on, right? So for gender, we either enter a number which is, 0 or 1. Same for married, the number of dependencies, this here can be any number with regards to how many dependencies the applicant has. Then 0 or 1 for education, it can be 0 or 1 for self-employed. Then the income here will then be however much the applicant is earning. If the applicant is married, you add your co-applicant income. If they're not married, you add 0. So as you can see, this one is not married. It's 0 under the married column. So it will also be 0 under the co-applicant income. If it is married, you have to enter the co-applicant income here as well. Then the loan amount in which they will be taking out, you enter in this column here. Then you enter the loan term in which they intend to pay the loan over. Then the credit history as well, if they have that available or not. Then from there, we'll then go ahead and predict. So let's just go ahead and enter these numbers for our model and see exactly what we get. So if you go ahead and enter maybe for gender here, I will use 0 initially. Then for married, I will use 0. Then number of dependencies, we can just use a number like 2. Then if they're educated or not, this can be 0 or 1. We'll enter 1 for educated. Are they self-employed? We can enter 0 here. Then applicant income, this can be any number. So I'm going to enter maybe something like 10,000 in here. Then because they are not married, I will leave co-applicant income as 0. I will then enter how much they want to take the loan for. So in this case here, we can maybe do something like maybe 5,000 rand, 5,000 rather. So then from there proceeding, we can then have a loan term. So in this case here, they can maybe pay the loan over maybe a 36 loan term period. Then the credit history, you can say it's available. Then we can enter 1 for housing here and also 1 for locality. So this here will be sort of the various unique attributes for someone who's applying for a loan, for example, right? So if I click on add to list here, this will then be the string or the what gets the input list that gets sort of sent into our model. Then from there, when I click on predict, we'll then get a response which then says if the person is likely to be a fraudulent claim or not. So in this case here, as you can see, the value we get here is 0. So this person should be fine for our loan. And this here is the sort of the accuracy measure that we actually sort of predicted by our model. Then you can do this here for many number of people and we generate various results for them. So we can just try again just one more time to see another example for this here. So you can enter maybe in this case 1 for gender. Then maybe if they are married, maybe let's say they have 6 dependents. Then maybe they have no education. Maybe they are self-employed. Then they have an income of maybe like 1,000, for example. Then their spouse, the income of 1,000 as well. Then maybe they want a loan amount of something like 5,000, for example, and they want to pay it off in 4 terms, for example, right? Then they have no credit history. Then maybe they have housing and locality, that's fine. Then if I just add this to list and just click predict again, it will run a different prediction for this one as well. So as you can see the values here, this one will then be for prediction number 1. Then this one will then be for prediction number 2. In this case here, as you can see, it's more likely to be a fraudulent transaction given the data we've entered in the previous input data here. Okay, so I think that should be our model in a nutshell. So I think what I will do now is I will just hand over back to my colleague who will then finish up for today. But just a quick reminder, you have an ability to then proceed as a Jupyter notebook here using these steps here. So please feel free to come back a bit later on to this GitHub repo and then try this out on your own. Okay, thank you.
All right, thank you, Sibusiso, so much for this great hands-on. Let me just go ahead and share back my screen. Okay, so just to make a quick recap of what we have done so far in this workshop. So basically, just let me share my screen again. I have some kind of lag. All right, yeah, sorry for that. So just a quick thing here, guys, because there were a lot of questions happening on this part. So basically what we want to predict is the fraud risk, which is this specific field. And we're doing this without code. So we have uploaded this data set into AutoAI. We told AutoAI what is our target field, which in this case is the fraud risk. So the fraud is already filled with values 0 and 1s. And we are using this data, we're splitting it into halves to train it and then to evaluate it, to test it with what we have. And the way it works, we are using all these other fields as predictors to predict the specific field, right? So we're using the values of locality, housing, credit history, all of these to be able to see based on what we are getting the 0 or the 1 value, which represent whether we should accept this loan or reject this loan. So this is just a quick summary of what we were doing. And based on that, AI will select the model for us, we'll rank them, we can go ahead, choose the best one and save it. And another quick thing here, just we want to show you that because when you want to test your model, there's a lot of fields that we are using as predictors. So for this specific case, there is a sample data JSON that you can simply just copy this, and you can go ahead and paste it in the testing phase. So if we go back to the testing, but just like Sibusiso was doing here, he was putting the data. If we click on the input data as JSON, so in this case, you can just paste the JSON code right here and go ahead, click on predict, and it'll show you the results. It's just a faster way in case you want to test it for this specific use case. So let's go back to our presentation. So again, this is what we were trying to do, to build the model for a fault-tolerant application. We did this with AutoAI. We compared some different models, and we went to saving it and deploying it on the IBM Cloud. And all this was just with clicks, so we didn't use any line of code. These are some useful links that you can check them out from. So the first one is just the registration link for IBM Cloud to sign up for your account. The second one is the hands-on steps. So this is the GitHub repository that we were using for this specific workshop. And we want to share with you a very important link, which is the IBM developer website. Feel free to check it out. Basically, if you want to learn any technologies, blockchain, microservices, data and AI, security, anything that you want, you can simply go there and find any content that you want. There's videos, tutorials, code patterns that will help you to grow your skills in a specific technology. And last but not least, we have our meetup link, so you can go ahead and follow us there and to keep yourself updated with all the events that we're doing in case you want to attend any event that you're interested in. So that's it for today's session. Again, this is just the first session. We have now many upcoming sessions. So great things are coming. We just want to thank you all. These are our contact details. You can reach us at any time in case you have any questions. And again, this survey, please, we'll really appreciate if you can fill it. Again, we just have a couple of questions. You can just fill this in a couple of seconds anonymously. And that's it. So with that, we'll go back to our host, Fawaz. The stage is all yours again.
Thank you so much, Khalil, and thank you so much for such an amazing session. I believe that AutoAI is an amazing tool, and automated machine learning is growing day by day, given the skills gap that we have. Now, for our next session, we have something very interesting. We have an external speaker, and we have Geeta Atkar, who is an assistant professor at G.A. Rasouni College of Engineering and Management. And she'll be talking about speech synthesis by using advanced machine learning techniques for easy readability of dyslexic children. So Geeta, I believe you're on stage, and over to you.
Yeah, sure. Thanks a lot for giving me an opportunity to present my skills over here. First of all, I would like to welcome all in Digital Developer Conference on Data and AI. So here, I am Geeta Atkar, working as an assistant professor in G.H. Rasouni College of Engineering and Management from last 11 years. I am here to present my topic on speech synthesis by using advanced machine learning techniques for easy readability of a dyslexic children. So these are some of the agenda which I'm going to cover in my presentation. The first is dyslexia in children. What is the actual dyslexia occur in a children, and which data set I have used for speech synthesis technique for the dyslexic children. And then we are going to focus on a generative adversarial network, that is waveGAN and mailGAN part, which can be applied on the input speech. And then the results which I have got through this waveGAN and the mailGAN, and some of the conclusion part we are going to learn. So here, first of all,
Hey, Geeta, Fawaz here. Can you just hide the stop sharing section? Just like click on hide at the bottom of the screen. At the bottom. Yeah, just click on hide. Yes. Thank you.
Oh, welcome. Okay. So here, most of the people are not knowing about the dyslexia. So generally, this dyslexia occurs in the early age of the children. Around 6 to 10 years of the children are facing the problem of dyslexia. Around 60 to 70% of the children are facing this issue. So what is dyslexia actually? It is nothing but a learning disability which occurs in the children. So learning in case of, there are a number of types of dyslexia available currently. So like some of the children are facing the problem of dysgraphia, some of the children are facing the problem of dyscalculia, and some are facing dyslexia. So here dyslexia is nothing but the reading disability which occurs in the children. Normally children are not able to find out the differentiate between the small b and small d, or small m and small w. So this is nothing but the readability problem occurs in a children. So as compared to normal children, these children require a more time to grasp the things. Similarly, if some of the children are facing the problem of dysgraphia, so dysgraphia is nothing but the writing disability. Most of the children are facing the dysgraphia issue in the early age, we can consider. Along with that, some are having the problem of dyscalculia, means they are not able to find out the differences between like addition and the subtraction, how to add the things and how to subtract the things. So the main our focus is here on speech synthesis. So here we are going to give normal audios as an input to the system, and then those audios are given as an input to our speech synthesis technique, and we will generate a multiple speeches so that we can train our system by using the speeches. So here this is a general architecture as it is a social problem. So here we are going to give a 2 and 3 letter words as an input to the dyslexic children, and then we are going to apply the speech synthesis techniques. That may be a generative adversarial network. Here we are going to know about that. So whatever speeches are generated from that generative adversarial network are giving as an input to the system, and then our system will be trained by using those words, and then the system will allow the child to read the word which is displayed on a screen, and if that child is reading that word correctly, then system will give him a next word to read. Otherwise, the system will give the child to read the words once again 3 times, and still that particular children is not able to read that particular word. So the system is giving some of the clues, or it is giving like system is speaking out the word so that children will come to know about what is that word actually. So in this way, this is a general architecture for helping the dyslexic children, or we can say assisting to the dyslexic children. So here you can see here in the second step, we are using the speech synthesis technique. So here the data set used for that speech synthesis technique is speech command 0 through 9, that is SC09. And this is the data set which was used by Google, and it is a subset of that particular data set. It consists of around 65,000 of a clip of 1 second long duration. Each clip is having the duration of 1 second, and that clip consists of 30 different words which are spoken by thousands of people. And all these clips are recorded in a realistic environment, like on phones or the laptops. So this is a data set which I have used here. So as I told you, for the speech synthesis technique, this is a simple architecture for generative adversarial network which can be used. So here the basic main 2 components are present, that is generator and we can say discriminator. Okay, so here the function of this generator is to take a training data. As from the data set we have given the inputs as an audio, so it will take an input, a training data, and then this particular generator will introduce a noise into the training data, and it will generate a data. And the discriminator part works on the outputs which the discriminator part got from the generator and the training data, and from that this discriminator will find out the differentiation between the real and the fake data, and then we are going to compute the similarity scores from original and the generated speech. So this is how the general GAN works. So here we are going to know about the two main case studies. That is, first is wave GAN, on which I have worked, and second one is mail GAN. So here why I have chosen this wave GAN, because while using audio files as an input, there are most of the issues are faced by DC GAN. So for that purpose, here the wave GAN is chosen. So while considering the images as an input, we are taking the two-dimensional filters for that purpose. So, but here for the audio, we are taking a one-dimensional filters as an input for length of 25. And here the upsampling rate is also high, that is around 4. As compared to DC GAN, it is more. So that whatever outputs we are getting through the speech synthesis part, so that will be a best. So for that purpose, here the upsampling factor is high. And again, while considering the DC GAN, there are phase shuffling issues are occurring. So for that purpose, this phase shuffling is used in the wave GAN part. Okay, so this is the first case study, which is more accurate as compared to the DC GAN. And while comparing this wave GAN with the mail GAN, so the mail GAN again consists of the two different components, that is mail GAN generator part and mail GAN discriminator part. So here the mail GAN generator uses a 3 network layers architecture, and generator has a convolution layer and 2 upsampling layer, which is followed with the residual stack. You can see here in the diagram, and then that residual stack is having a dilated convolution block. Okay, here again the Leaky-Relu function is used for an activation function. So this is just an architecture for mail GAN generator, and then here this is the architecture for discriminator part of the mail GAN. So here 3 different discriminator are used, that is D1, D2 and D3. So these blocks are used here. So in that D1, for the D1, the raw waveform is taken as an input, and for D2 and D3 discriminator, you can see here in the figure. So here for D2 and D3, we are using the audio which is downsampled at a 2 and 4, the factor at 2 and 4. And then here each discriminator is having convolution layer and 4 downsampling layer, along with that its own feature map. And the Leaky-Relu function is used again here for activation function. So these are just the results, which sample results which I have got by using this mail GAN on for the speech synthesis. So this is an input waveform, or the waveform for the input sample audio, and this is a generator waveform which I have got. Okay, and while comparing the results of WaveNet, WaveGAN and the mail GAN, it is found that the mail GAN is giving the best accuracy. So here the similarity score in between the original waveform and the generated waveform is done by using the minimum optimum score. So here you can see the mail GAN is giving the most similarity as compared to previous two techniques. So this is a graphical representation, or we can say for all 3 techniques. Here you can see the comparison in between original waveform and the WaveNet, WaveGAN and the mail GAN. Okay, so now while considering some of the programming perspective for using the GAN on IBM Cloud, so here you need to create an account with IBM Cloud and then install the IBM Cloud CLI and then log in. After installing, log into your IBM Cloud account which you have created, and then set up IBM Cloud Target org and the space. After that, you need to clone the Github repository and then create a GAN configuration file. After that, edit the manifest and the prop file and push the app to a new Python runtime in a cloud, in the IBM Cloud. So this is a general a thing how to use the IBM Cloud for GAN, and then how the speech synthesis can be done by using a different libraries of the Python. So first of all, you need to create a JSON config file that defines the architecture choices of the GAN model to be trained, and then send that JSON config file to a Python Flask server in IBM Cloud through REST API call. And then the Flask API decodes the JSON config file and creates a GAN model definition. Then that Flask API converts a GAN model definition into an error-free PyTorch code. So this PyTorch code is then trained by using a given input audio data, which we have taken from our dataset. And then train model generate whatever model we are going to train, that will generate a new fashion audio which are not already present in our input data, but they are similar to our input data. They look similar to our input data. In this way, we can generate a speech by using this PyTorch code, and then whatever newly generated audios we are getting, that will be collected from the IBM Cloud. So this is just a programming perspective for how to generate audios by using GAN. And so what I would like to conclude over here is, while comparing waveGAN and mailGAN, the accuracy given by the mailGAN is more as compared to wavenet and the waveGAN, because mailGAN shows a lot of future promise for audio generation, and primarily for being fast and being able to generate a long audio samples as compared to the other previous models. So here I just want to conclude that for using the mailGAN to get a best possible result and best similarity score while comparing along with the original waveform. So this is all about the mailGAN. So if you are having any queries, or you want to ask me anything, or you wanted to contact me, you can contact me on my given mail ID, that is geet.121@gmail.com. So
Thank you so much, Geeta, for such an amazing presentation.
I would like to thanks Fawaz Siddiqui sir for giving me this opportunity to present my skills and my research. Thank you so much, sir.
Thank you. Have a great day. So
Thank
that
you.
was amazing talk by Geeta Atkar, and I think mental health is a big issue these days, and it needs to be covered up. So yeah, really amazing work, Geeta. It's really interesting to see your research here, and we are really glad that you were a part of this conference. Now we'll be moving on to the next session, and I think you need to stop sharing so that I can share my screen, if that's okay with you. You can just click on the X. It's inside. All right. Geeta, your screen is still being shared. If you can.
Okay, sir.
Yeah, thank you. All right, so our next session is something really, really nice. Just in the previous session, we had Geeta Atkar using tech for good for helping fight mental health issues. Now we have building a recurrent neural network using TensorFlow and Keras. So we have Mridul Bandari, Anam Mahmood, and Emeka Boris Ama from the OSCA Open Source and Community of Africa. And he's a lead data scientist at Law Pavilion, whereas Mridul and Anam are developer advocates at IBM. So Mridul, Anam, Boris, over to you. Rock the stage.
Thank you, Fawaz, and good evening, everyone. I'll just share my screen. Just give me a moment. Okay. Okay, just give me a minute. some issue. We'll try again. Okay.
Anam, you want to try refreshing?
Yeah, just give me a second. Can you see my screen now?
You can see it. Right,
Okay.
over to you now.
Sorry for that issue. First of all, good evening, everyone. My name is Anam, and I'm a developer advocate at IBM. With me today, I have my colleague Mridul, and
Anam, sorry to interrupt you. I think the crowdcast screen is being shared, not the presentation. Can you change that, please?
oh, really?
Yeah. If you're having issues, I can share the screen.
Yeah, can you share your screen? I don't know why I can't share my presentation.
Sure. Okay. We need to stop sharing. I'll just start sharing it.
I'm really sorry for the issue, but in the meantime, I would like to take this opportunity for Amika to go ahead and introduce himself, and then followed by Mridul introducing himself, and then we'll get started with our session.
All right. Emika, are you there?
Hi, everyone.
Yeah, Amika, please go ahead and introduce yourself.
Okay. Hi, everyone. My name is Emeka Boris Emma, and I currently work as a lead data scientist at Law Pavilion, where I build machine learning model for the legal ecosystem. Currently, I also have an open source project, TensorFlow Text Generator, which actually help you build a custom text generation model with TensorFlow. I'm super excited to be here, and I look forward to my talk.
So yeah, good morning, good afternoon, good evening, everyone. Thank you for joining us today. My name is Mridul Bhandari. I'm a developer advocate at IBM UAE, and I'll be taking you through I'll be one of the presenters for this session today. Over to you, Anam.
Thank you, Mridul. Thank you, Boris. So now for our session, so moving on to the next slide, I'd just like to go for our session today. It's about building a recurrent neural network using TensorFlow Keras. And just to start with some housekeeping, we have on your screens, you will see on the top left, you will find the introduction to serverless applications on the topic of the session. And then if you click on the I button, you'll find more information about the event. You can follow us on IBM Developer, and every time we go live, you will get notified about our events. And you can also find our upcoming events. You can chat with everyone. As you can see, there's a lot of chat happening, so you can chat with everyone in the chat section. If you have any questions, you can post them in the Q&A session. And for the resources, you can click on the Get Started Here link to sign up to IBM Cloud. Now, moving on to our agenda for today. We'll be talking about deep learning. What is deep learning? Tools and frameworks for deep learning, neural networks, convolutional neural networks. What is TensorFlow? Why TensorFlow? What is Keras and why Keras? Which will then be followed by the hands-on session by Mridul, and some resources that we'd like to share at the end. Now, moving on to what is deep learning. So the difference between the terms that we hear on regular basis now, starting with artificial intelligence, AI refers to the ability of computer systems to act like human being by performing tasks that you would normally associate with humans. So tasks like learning, communicating, self-correction, etc. And a very common misconception about AI is that it is supposed to replace humans, whereas that's not exactly accurate. But actually, it's supposed to augment or enhance our abilities as humans to allow us to solve even more complex problems. So artificial intelligence is a technique that enables machines to mimic human behavior. Basically, it's a broader concept of machines being able to carry out tasks like carry out tasks that we would actually call smart, like a program with the ability to learn and reason like humans and solve tasks but with this we don't have any idea of how we will solve these issues, and this is where machine learning comes in. So with machine learning, it's the current application of AI where the system improves their performance in a given task using statistical methods and data given. And deep learning is a subset of machine learning that uses neural networks to analyze different factors, classify images, and so on. So deep learning is basically the next evolution of machine learning, and this is the hierarchy where AI, which is a technique to make machine intelligent, and then ML, where you use statistical methods and algorithms to solve problems and make predictions. But last but not the least, we have deep learning, that uses neural networks to classify images and speech recognition. Neural networks are inspired by the structure of human brain, and that's the whole concept of deep learning and how it works. Now, moving on to the next slide, we have some frameworks of deep learning. And so we have NLTK for natural language processing. We have scikit-learn for which is one of the most popular libraries of machine learning. And we have pandas, which is used for data exploration, and PyTorch. And we have PyTorch, TensorFlow, and Keras, which is the topic for today. Now, next slide, we have, so the major difference between deep learning and machine learning is that deep learning uses neural networks, which are inspired by the structure of the human brain. Now, artificial neural networks, often referred to as simply neural networks, take inspiration from the biological neural networks, although they work in a different way, but they still take inspiration from the biological ones. And a neural network in AI is a collection of small computing units called neurons that take incoming data and learn to make decisions over time. So neural networks are often layer deep and are the reason why deep learning algorithms become more efficient as the data set increases in volume, as opposed to other machine learning algorithms that may plateau as data increases. So on the next slide, neural networks, I like to talk about neural networks that refer to systems of neurons, either organic or artificial in nature. And they have dendrites that act as the input node and axons that act as the output node. So the input layer basically represents a feature and that sends data to the subsequent layers for processing. Then comes the hidden node, where we perform some sort of mathematical operation, and then we have the output layer. Now, for convolutional neural networks in the next slide, so convolutional neural networks, or CNN, is an artificial neural network that is popularly used for analyzing images, but it can be used for other data analysis and classification problems as well. So we can think of a CNN that has some type of specialization for being able to pick out or detect patterns and make sense of them. So this sense of them and the pattern detection is what makes CNN so useful for image analysis. So now what makes CNN different from a neural network is the hidden layers. And now, so the hidden layers is what is called convolutional layers. Now, with each convolutional layer, we need to specify the number of filters and layers that the layer should have. And these filters are actually what detect the patterns. So now moving on to the next slide, let's look at an example. So we have a convolutional neural network that accepts images of handwritten digits. And our network is classifying of whether the image is going to be a 1, 2, 7, etc. So let's now assume that the first hidden layer is our model. In our model is the convolution layer, as mentioned earlier. So when adding a convolution layer to a model, we also have to specify how many filters, we want the layer to have. So a filter can technically just be thought of a relatively small matrix for which we decide the number of rows and columns it's going to have, and that is initialized with random numbers. So for this first convolution layer, in this example of ours, can you go to the next slide, Milo, please? Example of ours, we're going to specify that we want the layer to contain one filter of size 3 by 3. And now this convolution layer receives input from the filter, and this filter will slide over each 3 by 3 set of pixels from the input itself until it slides over the whole matrix. So looking at the pixel image here, our 3 by 3 filter of random numbers. So here, when the filter first lands on the first 3 by 3 block, it does the dot product of the filter, and then it saves the output in the next matrix. Okay, so it's and then it computes it, and then it stores it into the next matrix, and after the filter convolves, so it would look like the dot product of the filter here with the first 3 by 3 block, and when we store it over in the next matrix, it just keeps adding those up, and that's how we calculate the neural network of the system. Now, that's CNN, and I'd like to hand it over to Mridul to Boris for taking over to TensorFlow.
Okay, hi everyone. In this section, we're going to learn about TensorFlow. So before I begin, I just need to introduce myself again for those who actually missed. So my name is Emeka Boris Amar. A lead data scientist and also an IBM champion. And also I have an open source project, TextGen, which basically is built on top of TensorFlow. So TensorFlow is an open source library that's primarily for deep learning application and also support traditional machine learning. So TensorFlow actually accepts multidimensional array of high dimension, which are also called tensor. So in TensorFlow, we basically have three particular concept, which is the node, the edges, and tensor. If you're familiar with that, so the node is basically a graph that's a mathematical operation, or that represent a mathematical operation, and the edges of graphics that represent a multidimensional array, and these edges are also called tensors. But of course, you must have heard that tensors are generalization of vectors and matrices, which are easily understood as multidimensional array. Next slide. Okay, so why TensorFlow? With TensorFlow, you can basically build a machine learning model easily. You can basically build a robust machine learning model scalable anywhere, and also deploy a machine learning model in production anywhere, either on mobile or the web. So TensorFlow actually supports both CPUs and GPU for computation devices, and also you can use TensorFlow to convert a research paper or your research to production. So with TensorFlow, you can basically build a voice recognition, an NLP model, video detection, image recognition, time series analysis, classification, and regression tag. TensorFlow is actually a world of possibility. With TensorFlow, everything is possible, in my own opinion. And I believe that there are a lot of amazing applications out there built with TensorFlow. Next slide. Okay, so continuation of the why TensorFlow. With TensorFlow, you can basically deploy in various places. Using TensorFlow 7, you can deploy on the web. Using TensorFlow Lite, you can deploy on Android, iOS, or Raspberry Pi. Using TensorFlow JS, you can also run your machine learning model on the web. So there are other platforms that can actually help you see pre-trained model like TensorFlow Hub. You can see save models on TensorFlow Hub that you can basically use instantly instead of having to build your model from scratch. Next slide. Okay, so when I talk about possibility with TensorFlow, I also want to talk about how simple it is for you to actually build a model with TensorFlow. This is actually the TensorFlow version 1, and you can see the line of code it takes for it to build a model. But in TensorFlow version 2, you can basically build your machine learning model in a single line of code. So with TensorFlow version 2, everything is possible. Less code, more action, or less code, more uh, models, and also a lot of things. So let's move on to the next slide. Okay, so while we're done talking about TensorFlow, it's important that we talk about Keras. And Keras is actually a high-level neural network library that runs on top of TensorFlow. And a lot of people say that Keras is built on top of TensorFlow, which is actually accurate. So Keras is actually developed to actually focus on enabling fast experiment, being able to go from possible from research to production very easy. So with Keras, you can basically build your machine learning model with ease, and it's something similar to TensorFlow, but we believe that these two deep learning libraries are actually give you that particular platform for you to build a machine learning model with ease. Next slide. Okay, so let's talk about why Keras, and it's important to understand that a lot of reason why you should use Keras, and also why you should actually use Keras to build your next machine learning model that can actually scale on anywhere, either the cloud, your mobile application, Raspberry Pi, or your iOS devices. So with Keras, you can basically move from research to production, less code, deploy anywhere, and you can build any architecture or any deep learning architecture with Keras. So thank you so much. And I'm going to move the mic to Mujul for the hands-on section.
Thank you, Amika. I'll just reshare my screen for just a minute. Right. Good morning, good evening, good afternoon, everyone. Thank you for joining us today. I hope you're all safe and doing well. So I'll be taking you over to the hands-on session and in that I'm going to show you how to build a recurrent neural network model using TensorFlow and Keras. Now, these are some few important links which we'll require for a hands-on session today. So the first and foremost, we need to sign up for the IBM Cloud account. So the link for it is ibm.biz/MEA-data AI. The link will be shared with you in the chat section. So you can go over there and click on the link and register. The next thing is we'll be, the hands-on session is also there. It's all detailed and it's documented on this link, ibm.biz/MEA-data AI-NN lab. And the Github repository is available at ibm.biz/MEA-data AI-NN repo. And the slides for the session are available on ibm.biz/MEA-data AI-NN slides. So all these links will be shared with you in the chat. So you can go ahead and you can register for your IBM Cloud account and you can access all the resources which in the for the session in the links in the chat section. So all the links are available there. Then we have the survey. It is really important for us to understand how we are doing and how we could improve. So we have the survey link displayed on the screen, which is also shared with you in the chat. So you can scan the QR code from the screen with your phones, and you can fill the survey. It will take only a minute, but it really helps us understand what you want to learn about and how we could improve. So firstly, let's we'll register for the IBM Cloud account. So I'll just show you how to do that. So you can open a browser and click in the search, just write ibm.biz/MEA-data AI. So once you click search for this link, this should open the IBM Cloud sign up page. So if you are a new user, you can fill in your details over here. All you need to do is enter your email ID decide a password, verify email, have that passcode which comes to your email, enter it over here, and you create an account. It is as simple as that. So it will only take around 15 seconds to create an IBM Cloud account. So please go ahead and register for this. I have already registered, so I will not be registering again. I will not be filling my details again, but I would request you to do so. So for now, I will just continue, with my IBM Cloud account. So the link is available in the chat section. So please go ahead and register over there, and you use the link from there, and you can register. And once you register, a page should open up which shows the dashboard of your IBM Cloud account. So over here you can see some few resources which are available, like if you want to monitor your resources, explore some analytics engine, and getting started with machine learning in Watson Studio. So you can go ahead and click on these links to see the details. And below that we have the resources. So this is the summary of the resources which are available. So we have the services which we have created would be available over here. They'll be listed over here. So I've only created one service, so that is available over here, and I have one storage service which I've created, so it's available over here. It's listed as one. If you're a new user, you wouldn't have this listed, so it would be 0 for you. So I'll show you how to create a service in the next step. And then we have the planned maintenance and other sections in case you want to keep yourself updated. If there's any maintenance or if there's any update with our services that is going on. So we have all that over here. So on your dashboard, you can get all that information. It is very simple. So please go ahead and register using the link which is shared with you in the chat and create your free IBM Cloud account now. So moving on, let's go ahead and I'll show you how to get see the GitHub repository which I've shared with you. So again, you can go on this link ibm.biz/MEA-data AI -NN repo. So this is the repository link. So you can go to this link and you can access the GitHub repository which we'll be utilizing for today for our hands-on session now. So this repository is here. You can download this repository either as a zip or you can open it with GitHub Desktop. Though you do not require to download this GitHub repository for this workshop, because I'll be showing you how to use this the code without downloading the repository. But if you still want to, you can go ahead and you can clone this repository. So you can download it as a zip or you can open it with GitHub Desktop, whichever is your preferred method. You can go ahead and download the repository. But you do not require to do this for this workshop. So if it's fine if you don't download it now. So now, moving on, we need to create an IBM Watson Studio service for our session today. So I'll just show you how to create an Watson Studio service. So you can go in the search bar over here, and you can search for Watson Studio. So you can see this, and the catalog results, you'll see Watson Studio service. So click on that. So once you click on that, a page should appear which will show you, a page how to create to select the location and everything. So this is the page where we create the Watson Studio service. So in this, we'll have to select the location. We have to select the pricing plan and everything. So firstly, for the location, let's select Dallas. Dallas right now is not under maintenance, so we have just checked it out. So you won't face any issues. There's no maintenance going on. So you can select the location as Dallas to be on the safe side. The next thing is the pricing plan. So for our session today, we just require a light plan. So you can click on this, select the light plan, and that is sufficient. You do not need to enter your credit card details at any point. So you don't need to worry about giving your credit card information at anywhere. So you can select the light plan, and if you scroll a bit down, there's a service name. So you can change the service name to whatever name you would like to give it. So you can give it MEA-data AI. So that can be the service name which you want to give, and the resource group should be default, and you can add tags to your service. But that is not compulsory. So we'll skip that over for now. So once you're done with that, on the right hand side, this create, but there's a tab which shows you the summary, which shows the location, the pricing plan, and the service name, and the resource group. So it mentions a message that I have an existing light plan instance already existing for Watson Studio. So I'm not able to create. So if you have a light service for Watson Studio already existing, you should delete that service, or you should reuse that service. Depends on your preference. So I would recommend just delete that service so that you can create a new service. So you'll have new capacity unit per hours monthly limit, which will be reinstated, so that you can follow the hands-on session today. So once this create button turns blue, you can go ahead and click on that. So meanwhile you're doing that, I'll just explain a bit about Watson Studio. So Watson Studio is a data science platform that provides all the tools necessary to develop a data-centric solution on the cloud. So it uses Apache Spark clusters to provide the computational power to develop complex machine learning models. So you can choose to create assets in Python, Scala, R, and you can use open source frameworks, which we'll be doing today, such as TensorFlow and Keras, and that are already installed on Watson Studio. So you can go ahead and you can read about Watson Studio, more details about Watson Studio on this about section. You can see the videos. You can see how people are using their data products to increasing the production, decreasing the production time, and giving better. If they're able to build better products using Watson Studio. So again, when you go to create section, click on create. Once you're done with that, it should take you to a Watson Studio page. So for now, I've created my service. So I'll just go to the resource list. So for that, you can click on the hamburger menu in the left-hand side top corner. So once you click on that, you'll have the resource list. So click on the resource list. Once you have the resource list over here, you can see Watson Studio -MEA -Data AI. So you can click on this. That is the service I've created. So once you click on this, this page should appear, which shows the service details about Watson Studio. So once you're over here, you can click on Get Started. So yeah, so once you come to this page, it will show you the Watson Studio dashboard. So over here we have the projects, we have the deployments, and we have the various sections over here. So what we're going to do is we're going to head over to this hamburger menu again, and we're going to create a project for us to work on. So projects are listed over here, so we can click on the View All Projects button, and we'll wait for it to see the project. So I've already created a project so that it shows the project is created over here. So let's create a new project. So let's click on this button plus new project. And then let's click on create an empty project. So once you click on this, let's give a name to our project today. So this is Recurrent Neural Network, so RNN, that's the name of the project I'll give. And there's a cloud object storage service which we need to create. So cloud object storage service is where our data is stored. So we need a storage service to store everything we are doing today, all the project details, the assets and everything. So for me, I've already created an object storage service. So you'll have an option to create one that will be a hyperlink. So you click on that and a page like this should appear. I'll just show you the page. So object storage service page should creation page should appear. So page like this should appear. Yeah. So it will be the same page as Watson Studio. So over here, you do not need to select the location. Pricing plan, you could select as light. That is sufficient for workshop today. No need to enter your credit card details. And you could change the service name to what you would like to. So it could be anything. So let's say MEA -Data AI. So you can go ahead and you can select, change the service name. The resource group should be default. And then you can click on the create button. So once you're done with that, you click on the create button. Service should create. If you want to read more about object storage service, you can go on the about section. You can read about it. So it will mention it's a highly scalable cloud storage service, which I summarized it earlier. So you can go in details and read about it over here. So once you're done creating with this, you can come back to the Watson Studio project creation page. You can click on refresh, and it should show the drop-down menu with the object storage service you've created. So for me, I have this object storage service created. It is already selected as that. And then I'm going to click on create. So once you click on create, let's give it a few seconds to create the project space for us on Watson Studio. So yeah, once it creates a project for you, we'll head over to an overview page. So this is where your activity would be listed. So there's a README document which you can use to document your steps. So you can collaborate with multiple people, and you can document those steps over here, so that while you're collaborating with multiple people, it is easier to see what step you're on, what is the objective of the project, and those details. So you can document these things over here. Then you have the recent activity, which is listed over here. As you've just newly created this project, there's no recent activity, and this is the number of collaborators. So if you want to add more collaborators, you can click on view all, and then you'll have an option to add collaborators. So you can click on that. And once you're done with all this, you can head over to the assets section. You can see on the top over here, assets section next to the overview section. You click on that. And now we're going to be using, we'll be creating the Jupyter notebook for our workshop for hands-on session today. So for this, please click on the Add to Project button, the blue button over here on the top, and then click on the notebook section, select the notebook. This Add to Project button will show you various, services you could create, various assets you could create to, like a dashboard or a data refinery flow, or various other features which you want to utilize for your hands-on session. So as we're on a time constraint, I will not be going in detail over that. I will just be showing you how to create a notebook. But if you have any queries, you can ask them in the chat section.
Mridul, we can't hear you. Your voice is getting cut off. Mridul, we can't hear you.
Hey everyone, just a bit of technical difficulties. He should be joining us back soon.
Hello, Anam, are you able to hear me?
I can hear you, Mridul. Yeah.
Yeah, Mridul, we hear you.
Sorry about that. What was the last thing which you heard, so that I can try to cover that up?
You were showing the GitHub repository.
Okay, so I was showing the GitHub repository. Yes. So in the GitHub repository, I'll just repeat that step again. The link of of the notebook is will be shared with you in the chat section. So what you could do is, if you how we're going to use the link is, we go over to our GitHub repository, we go into the notebooks folder, and we click on the notebook, and then we click on raw over here. So once you click on raw, you'll have the link over here. You can copy this link and you can paste it over here in the notebook URL section, and then you can just give a name to your notebook. So as I mentioned earlier, you do not need to install a GitHub repository. So this is how we're going to do it. We're just going to copy paste the link, and we're going to use Watson Studio is going to retrieve the code from there. So this is very simple. So you do not need to install the GitHub repository. So you can select the runtime over here. You can select the default runtime, and you can just keep it as default. You don't need to change it, because that is sufficient for our hands-on session today. And you can click on create. So now this thing is going to take a few minutes to create. So let's give it some time. So yeah. So while we're going through the notebook creation section, so I'll try to tell you a bit about our hands-on session today. So in our hands-on session, we'll be focusing on language modeling. And language modeling is a task of assigning probabilities to sequences of words. And it's one of the most important tasks in natural language processing. And given that the context of one word or a sequence of words in the language can be changed, the language model is therefore trained upon these different meanings. And the model therefore should provide the most probable words or sequence of word that follows from the given sequence of words in a sentence. And so for this, we'll be creating a recurrent neural network. Recurrent neural network is a class of neural networks that works well for modeling sequence of data, such as time series or natural language. Basically, an RNN uses a for loop and performs multiple iterations over the time steps of sequences, and while maintaining an internal state that encodes information about time steps. So it can be easily constructed using Keras RNN API, which is available in TensorFlow. And TensorFlow is an open source machine learning platform, which was covered by MEA. So I'll not go in much detail about that. And in this tutorial, we'll try to perform a language modeling on Penn tree bank dataset. So this we'll be doing by creating an RNN using long short-term memory, that is LSTM unit, and we'll be deploying it on our Watson Studio platform. So now, so we have this notebook over here. So this also actually it has a lot of details. So we will not be going over through that due to constraint of time. So I'll show you how to run the few cells and how it works. So basically, Jupyter Notebook helps you execute snippets of code. So this helps you, break down your code into small pieces and run those and see the output.
Yes, you can also.
Hello. Okay, I heard. Okay. So this helps you run snippets of code, and you can keep seeing the output in the snippets of code, and it can help you understand how far along you have come and at which step you're facing an issue. So Jupyter Notebook really helps that way. So we run a few cells just to see how it works. So I'll just click on this. So this step, you're just trying to install the TensorFlow library and the NumPy library. So this will show you how this works, and it keeps installing. So you can see the step, what is the size and at what speed it is installing. And this will keep downloading download the TensorFlow module for us and the NumPy module. So this will proceed, and while this snippet of code is running, and we can run the next snippet also, so we can execute that. So let's wait for it to complete. So while it's running, there's been an asterisk sign over here, and once it completes, there'll be a number that will be shown over here. So we are just waiting for it to complete. So just let's give it a few seconds. Or we could let's because we have a constraint of time, we just run the next cell over here. So we just run this over here. So we can wait. So while this when this previous cell completes, the execution completes for the previous cell, this will automatically start the next cell, and this you can see a numbers come over here. That means the execution of the cell is completed. So what we could do is, instead of doing that for a single cell, there's an option we could click on the cell section, and we could run all cells over here. So we can click on that, and we can run all the cells below this. So it'll run all the cells below. Now, because the epoch over here is 15, this is going to take a lot of time. So this will take approximately 3 hours. But just to show you how the output looks like, I have run a few notebooks, and I've kept it on the side on different iterations of epoch. So this will keep executing, and this will take a lot of time. So I'll just show you that. Just a second. So I've executed a notebook with one epoch over here, and you can see the output over here. So this is it took a very less time for that. So I just generated and I kept it over here. So you can check this. You can try it with one epoch, and you can see the results, and you can play with the epochs. And I've also tried it with 5 epochs, and I've kept it over here, and you could see the difference between the output over here. So the total perplexity is 130.804 over here, and over here it's 203. So the more the epochs, the less the perplexity. Perplexity is basically the entanglement. So the lower the entanglement, that means the better the model is able to understand and predict from the training we have it has run over. It has been trained over. So you can see this, the different number of epochs will make a difference. So right now we have given 15 epochs, so it'll take a lot of time to execute. So we'll wait for this to keep running. You can keep running this notebook and keep it on the side, and you do not need to touch the notebook. But for the interest of time, I'll try to explain the other steps so that you're able to understand the data, the hands-on session more. So as I mentioned, what is language modeling? So I will not cover that. So I will try to explain what is the data set we are working on. So we have the pen tree data tree bank data set, which we are working on, and historically data sets have very big for natural language processing. We require large data sets for natural language processing, and which are really hard to come by. And this is partly due to the necessity of sentences to be broken down and tagged with a certain degree of correctness, or else the models trained on won't be accurate at all. This means that we need a large amount of data annotated by, or at least corrected by, humans, and this is not an easy task. So Penn Tree Bank dataset, or PTB for short, is a dataset that is maintained by University of Pennsylvania, and it is a huge dataset. It has over 4,800,000 annotated words in it, and it is corrected by humans, and it is composed by many different sources from abstracts of different departments and different papers and different contexts of text from the Library of America. Since it is verifiably correct and it is of such huge size, Penn Tree Bank is most commonly used as a dataset for language modeling. And in this, we'll be doing word embeddings. So what are word embeddings? So it is a way of processing or representing sentence structures or words as n-dimensional vectors. So Anam mentioned, what are matrices. So what are the vectors over there? So this is how it breaks down the word embeddings into small dimensional vectors, so that it's easier for us to process these models and train these models over the data sets. So basically in this, we basically assign a randomly initialized vector, and we input those into the network to be processed. And after a number of iterations, these vectors are expected to assume values that help the network to correctly predict what it needs to, and in our case, to predict the next word in the sentence. And this is shown to be an effective task in natural language processing, and it is the most commonly used practices for natural language processing in neural networks. So this notebook will keep on running, and this will take a lot of time. And as we're heading towards the end of the session, you can see the output over here. So in the networking session, you can go ahead and you can ask us any queries you have. So you can run the notebook. You can see the output over here, and we have the training and the testing model done. So as I mentioned, the perplexity decreases as the number of epochs decrease. So you can go ahead and go over to this cell over here, and in the cell under declaring the model hyperparameters, and you can edit the cell, and under max epoch you can change the number of epochs, and you can try out different epochs and run the model on different epochs to see the perplexity and how number of epochs decrease the perplexity, and you're able to get results from this, and you can compare those results also. So you can run different notebooks, compare those results, and you're able to understand how this a neural network works using TensorFlow Keras. So now I'll be passing over back to Anam to conclude the session and to share the useful resources for this, which will help you out to run this session. Anam, over to you.
Thank you, Mridul. Thank you for such a great session. Thank you, Boris. Let me try sharing my screen once again. Okay. Okay, so here are some of the resources. Wait, it's not. All right, so just moving to the last bit of it. Thank you everyone for staying with us throughout the session. And we've posted the links to the hands-on resources. You can sign up using to Ibm Cloud using this link here. It's also in the chat. And for the hands-on, you can follow along on these links, the GitHub repository. You can find the slides on the link over here. And do take the survey and let us know how we can improve or what you would like to see in the future. And if you're interested at speaking at any of our future events, you can fill up your name, and it's available to everyone. Some of the resources are to get started is the MEA and Data AI, where you can get started. Then you have the hands-on lab. And then for more of our sessions, you can join us on our meetup group. And if you want to look up at any of tutorials or any further resources, you can go to ibmdeveloper.com. And so if there is any thing that if you get stuck at anything or you would like to contact us, you can reach out to us using our emails, and you can follow us on GitHub for more information. And don't forget to take the survey and provide us your feedback. So that's it. I'd like to hand it over to Fawaz so we can bring up.
Hello. Hi, I'm back. So session Anam and Riddle. So before we go on to the next session, I want to talk about a bit about call for code. Let me share my screen. All right, and there we go. So what is call for code? Like I mentioned in the start itself, it's basically a challenge, a yearly challenge, I would say. And it's basically using tech for good to solve humanitarian and social issues which we face in our day-to-day life. It's always on, by the way. There are different challenges here. It goes on throughout the year, and we see some really amazing solutions which everyone builds in the community. So I would really appreciate if you do register for Call for Code. And why would you actually want to join Call for Code? It's basically you are going to build your skills. You're going to learn a lot of new things. You're going to be going for social good. You're going to generate your ideas to actions. And moreover, you'll be also contributing to open source software. And we have a really huge community. We have around 400,000 developers coming in from 179 nations, and who've actually built more than 15,000 applications. The award for Call for Code is around $200,000 for the Global Challenge winner, $10,000 for the University Challenge winner, and $5,000 for the MEA Region Challenge winner. Moreover, I'd also like to inform you about the main conference which we are a part of. It is the Digital Developer Conference Data and AI. It's free on demand. It's ongoing right now as we speak as well, and it's amazing. It's basically on demand. You can access it anytime. We have sessions on auto AI. We have sessions on different tracks. We have keynotes. We have AI in the wild. We have trending topics, tutorials for you to enjoy, and we also have lightning talks as well. We also have 2 courses which are available. And these 2 courses allow you to gain a badge. So course 1 is Jumpstart Your Journey. We also have a networking session to getting started with your career in data science within this session as well. And there's also Develop to Deploy. There's also a 24-hour live stream watch party going on. So you can 100% go ahead to Twitch and sign up for that. And we're going to be talking about various topics. We are going to be talking about debater APIs, trustworthy AI, NLP, automated machine learning. I believe we already have talked about automated machine learning in our session. We also have something about federated machine learning, which is something very new. We are covering data fabric, data ops, model ops, deep learning, and an open source technology, Call for Code, and every based on your career as well. And we're going to have career talks as well. So talking about Call for Code, I have a very amazing speaker. Her name is Gracia Napuentes. She is an independent senior researcher at the National Research Council and a group leader at University of Buenos Aires. And she was a part of Call for Code, and she She contributed to the early forest fire detection via machine learning. We had a forest fire based call for code session. And Graciana, I believe you are here, so over to you.
Indeed, thank you very much, Fawaz, for that introduction, and also thank you very much indeed for the invitation to participate in this event. Share. Can you see my screen there?
Not yet.
There? Yes.
Yes, now we can see your screen. Can you just hide the screen sharing message at the bottom?
Yeah, let's see.
And just click on hide. It's right there on the. It's the white color. No. It's the white color one. It says ocular. Yeah, that one.
That one.
Yeah. You're good to go. Thank you.
Great. So, first of all, I would like to thank Fawaz and the organizers of this conference for the kind invitation to present our preliminary results on early forest fire detection via machine learning using the IBM Cloud. I'm really glad to be part of this event. As you already heard, my name is Graciana Puentes. I'm a group leader at University of Buenos Aires and the National Research Council in Argentina. And again, I'm delighted to be here. So, as you already heard from previous sessions, machine learning can be considered a branch of artificial intelligence which focuses on the use of data and algorithms to imitate the way in which humans learn, gradually improving their accuracy. And basically, machine learning uses statistical methods and algorithms which are trained typically a neural network to make classifications and predictions which can uncover hidden information within the data. And let's mention that IBM was named leader in machine learning this year by Gartner. So it's located in this top quadrant for leaders on machine learning. So it's really a great place to start. So let's continue with a very brief introduction to machine learning, deep learning, and neural networks. As you already heard also from other previous sessions, we can consider machine learning we can consider deep learning as a subfield of machine learning and neural networks as a subfield of deep learning. A bit more specific, deep learning automates much of the feature extraction process, eliminating in this way the need for human intervention, which in turn enables to process larger data sets. In the works of Lex Fridman, which you probably have heard about, we can think of deep learning as scalable machine learning. And anyone who is interested to know more details about this, I strongly recommend these lecture notes by Lex Fridman at MIT. So deep learning in one slide, well, what is it? Well, as already mentioned in previous sessions, it's a powerful algorithm to extract useful patterns from large data sets. How is this done? Well, typically this is done using a deep neural network and optimization protocols, but more specific, how is it done? Well, typically in Python, in a Python environment, and using powerful packages such as TensorFlow, Torch Vision, and Friends. So what is the hard part? Well, actually, we have a very powerful tool, as you already saw from all the very nice talks today. However, in order to make good use of this tool, we need good questions and we need good data. So let's see here, we have a schematic which compares a simple neural network and a deep neural network. As you can see, the main difference is in the number of hidden layers. Typically, a deep neural network has a larger number of hidden layers, which enables the automation of most of the process. And this also enables applications such as pattern recognition, image classification, text transcription, machine translation, medical diagnosis, and so forth. So what I would like to concentrate, or the emphasis I would like to put in my talk today is what is a good question for deep learning. And I would like to argue that deep learning should be used to answer one of the most pressing questions of the 21st century, which I hope you will all agree is possibly climate change. So climate change is the long-term alteration of temperature and weather patterns in a place, causing weather patterns to be less predictable. And it's also connected with other damaging events, such as more frequent and more intense hurricanes, flows, downpours, winter storms, and wildfires, which will be the main focus of this talk. As you probably already know, a wildfire is an uncontrolled fire that burns in the wildland vegetation, often in rural areas such as forests, grasslands, savannas, and other ecosystems. While many plants and animals need actually wildfires, climate change has left some ecosystems more vulnerable to this type of flames, especially in the southwest of the United States and in the Amazonas, in Brazil, which, by the way, is the largest ecosystem in the planet. And here you can see an image of the latest fires in the Amazonas, which occurred in 2019. So this is a quite serious issue in America. So what I would like to ask is, what can artificial intelligence, and in particular machine learning, do to tackle climate change? So we have here a modest proposal just to keep the ball rolling, let's say. And the proposal here is to train a deep neural network to spot early forest fires and in this way prevent them. So our protocol is based on an image classifier, which is actually inspired by an excellent notebook written by Mostafa Abdelalem, who is an IBM developer. This image classifier is built to, originally it was built to classify a sign alphabet. It's written in Python 3.7, and it uses a CPU environment to train a deep neural network within Watson Studio, and this is run on the IBM Cloud. So I will say a few technicalities about our code, but because of limited time, I cannot go through all the details. But let's mention that we need two special packages. We need Kaggle CLI and Torch Vision. Kaggle CLI is the package we need to communicate with the databases. So basically, we have a data set on this located on this directory, and this is online and is accessible to everyone. You can actually check it if you're interested. Actually, to use Kaggle, you also need an account. You need a username and a key. So all of those are all preliminary steps that you need to do. And then we need Torch Vision, which is the package required for the image classifier. And within Torch Vision, we need a number of special libraries, which we install before starting. Then the next step is to load the images into the data loaders. This is done with the function image folder, which is within Torch Vision, so that's quite convenient. And then we customize the neural network using a predefined classifier. As most experts in machine learning will encourage, the idea is to use many of the predefined tools so that we can concentrate on asking a good question and borrowing tools that are already defined so that we don't need to reinvent the wheel, as they say. So the predefined classifier we are using here is logsoftmax, which is within the Torch Vision package. Once we customize the network, we can configure the neural network, and here is where we have the flexibility to choose the number of layers, the number of hidden layers, the number of neurons in the output layer, and the number of epochs. So this is really what makes the neural network particular, since every user can define this at their own will. So in this case, we are using only one epoch for training, and the training loop takes several hours. So we have to say it's not really efficient at the moment. And the reason for this is that we are running on CPU environment. In the future, we want to run it on GPU, but we need to make a few changes before. And once the network is trained, we test it. And the way in which we test it is by feeding images to the model. And then, the classifier has to classify the image. So we can obtain 4 possible outcomes for when we test the model. Basically, the images are classified as non-fire or fire. So it's a binary classification. However, the classification can be correct or incorrect. So we have 4 types of outcomes. For instance, this image is classified as a non-fire image, and the classification is correct, so we will call it a true negative. On the other hand, this one is classified as a fire image, and the classification is also correct, so we will call it a true positive. However, it could happen that an image like this one, for instance, is classified as non-fire, but the classification is wrong. This will be called a false negative. And the converse could also occur. For instance, this image is classified as a fire. However, the classification is incorrect, so this is a false positive. So with these definitions of events, we can actually quantify the accuracy, the detection rate, and the false alarm rate of our protocol. We define the accuracy as the sum of the true positives plus true negatives divided by the total number of events. The detection rate, we can define it as the number of true positives over the number of the total positive events, and the false alarm rate is the number of false negatives over the number of false negative events. In this way, we estimate roughly the accuracy to be of the order of 80%, the detection rate is of the order of 70%, and the false alarm rate is of the order of 10%. Let's mention that these are preliminary data. We started quite recently with this project, so we hope to improve this later on and obviously eventually publish this if possible. So the outlook for this project in particular is to improve the efficiency, since we mentioned that it takes a few hours to train the network currently. So the idea is to run it on a GPU environment in the future. And we also would like to improve the accuracy using larger sets of data, for instance, from a larger library in National Geographic. And then other things that we would like to test is to test other predefined classifiers within Torch Vision or within other packages. And eventually, the idea is that this would be a software that would be integrated in an automated surveillance camera, which could be connected to the cloud and controlled remotely with an application. And other applications of deep learning that we are developing with colleagues at the Center for Quantum Technologies is in the classification of quantum vortex states. This is done in collaboration with Center for Quantum Technologies in Singapore. So basically, the quantum vortex states are characterized by this type of phase maps, which sometimes present singularities. So if we can classify the number of singularities, basically we can classify the order of the quantum vortex, and this could have many applications for quantum information protocols, in particular for quantum cryptography. So the idea is to use deep learning to do this classification, which would enable to do this with minimal human intervention. And of course, this could add some interesting steps to the protocol. So with that, I would like to conclude. And the main takeaway from my talk is that I hope you are all convinced that deep learning is a very powerful tool. However, it requires good questions and good data. And what I would like to encourage everyone is to consider what is a good question for deep learning. And we could argue that possibly climate change is one of the most pressing issues of the century. So possibly this could be a problem to tackle with artificial intelligence and machine learning. And I hope you all agree that the IBM Cloud and Watson Studios is really a perfect environment to get up to speed with machine learning, since it has already a number of resources predefined. And as it was mentioned, it's also free at the moment, so that's great. And let's mention that some of these ideas will be submitted to the Call for Code for the Global Challenge Call for Code 2021, which will be based on climate change, as you already heard. So with that, I would like to conclude, and thank you for your attention.
Thank you so much, Graciana. This was amazing, and it's a really good thing that it was a part of Call for Code. And I'm going to reiterate to Call for Code as well. If you can stop sharing your screen,
yes.
Press on the X on the top of the screen. Yeah, there you go. Thank you. Let me just sorry, I'm was like on my screen. So about Call for Code, it's our yearly challenge, and Graciana did take part in this, and that's how she came up with the solution. And 100% you are aware now how impactful it is that you're joining a large community of developers who the main idea here is to solve social and humanitarian issues. And here it was wildfires. Why would you want to join Call for Code? Skill building, social good, ideas to action. And you'll be joining a community of more than 4,000 developers from 179 nations who've developed around 15,000 applications. This year's theme for Call for Code is towards clean water and sanitation. Providing clean water, it's been a big deal since a while. And I think it is time for us to act on it as humans. And it's very essential to provide clean water. to avoid disease spreading and all of these on many medical issues. Zero hunger is our second theme this year. It's very many people die of hunger, and technology can actually help grow crops in areas on the edge of drought, or quickly distribute perishables from small stores to local homeless shelters. So you have a vast area to cover up. And responsible production and green consumption. Technology can help make many recommendations on energy efficiency, actually, and allows us to be responsible consumers, I would say. So before we go in for a break, actually, I would like to talk about the main conference, the Digital Developer Conference, Data and AI. We have a course there, Course 1, which is Jumpstart Your Journey in Data Science. We're going to cover basics of Python and data science, basic of data exploration, analytics using Python and related libraries, basic AI model training in Python, automated AI model training using AutoAI, and deploying the results model as API endpoints. You will get a badge for this, so you can go ahead to ibm.biz/defcon-ai-badge to learn to attend those. Now, we are going to take some time and take a stretch, basically, and take a break. We have 2 more amazing sessions upcoming. We have one of our independent software vendors who is a gold partner with IBM, talking about brand-specific AI-based target management, and the networking session, where all of us will be with you face-to-face answering all your questions. We will start again at 8:25 p.m. GST. So if there's any questions which you'd like to ask, we are right here behind our screens, and we'll be answering your questions. Thank you, and see you at 8:25. All right, and we are back. It's 8:25, and we have our next session upcoming. So let me just introduce our speakers. So we have Yilmaz Miral and Serdar, who are IBM Gold Partner who are basically Gold Partner IBM Business Partners, and they offered Ziraat Participation Bank an analytic management solution, which was based on SPSS. And they're going to talk about brand-specific AI-based target management. And over to you, Yilmaz and Serdar.
Okay, thank you, Fawaz. I'm sharing my screen now.
It's okay.
Okay. Okay, can you see the presentation?
Good to go.
Yes, we can.
Okay, here we go. Hello and welcome, everyone. I hope you are all good and healthy. My name is Yilmaz Meral, and I'm here with my teammate Serdar.
Hello, everyone. I am Serdar Öztürk.
In this session, we are going to talk about our innovative approach, brand-specific AI-based target management. Before we start, I want to give some information about ourselves. We've been working for AIMS for 10 years. AIMS is a gold business partner of IBM and founded in year 2000 in Turkey, in Istanbul. As AIMS, we share a strong background in big data analytics. We develop analytical projects to solve business problems with using machine learning and AI algorithms for many sectors like banking, finance, retail, energy, and many more. Setting goals across multiple brands in a financial services organization can be a challenge. Almost everyone is familiar with the scenario in which annual targets are driven primarily by a percentage increase over the prior year's performance. With brand-specific AI-based target management, we developed an innovative approach to target setting. We designed a data-driven predictive analytics approach that using historical performance data, branch and portfolio characteristics, detailed demographic data, information about competitor locations, and more. These are the steps for brand-specific AI-based target management system. At the beginning, here you can see on the top, we customize our predefined multidimensional analytical data model with business users and IT users. In the second step, we give end users analytical trainings to learn machine learning and AI algorithms and terms, and how to develop this kind of models, how to interpret the outcomes and parameters, how to use analytical programs, and so on. After trainings, we start to prepare the data which we use in the project. Following the data preparation step, we start to segment brands and portfolios to define similar groups in terms of different point of views. After segmentation, we develop machine learning and AI models to forecast each portfolio and KPI with its own historical data. We develop different kinds of models, so we have different points of views. And then we design a champion-challenger approach to get best forecasted data. On the next step, we need to optimize actual and forecasted values to define targets for all portfolios and KPIs. We are going to do the target and budget optimization in the optimization step. After all these steps done, we are ready to use outputs. In the deployment step, we implement the outputs to our business process, like setting up new targets, creating new reports, monitoring the system, and more. First, we define the analytical data model that we use in the project. We use branch-based data like competitor locations and point of interests, city-based data like deposit ratio and loan ratio by all over the country, total amount of taxes, and internal and external group of data like branch and portfolio info, target price, total amount of loans in the competitor banks, and more. In the AI-based target management system, we have 5 different components. These components are the number 1, branch and portfolio segmentation, and number 2, forecasting the target KPIs, and the number 3, target optimization, and number 4, budget optimization phase, if needed, if the company needs, and the number 5, the last step, deployment step. We start with number 1, branch and portfolio segmentation. In the segmentation component, we define different types of segments for all portfolios. You can think like these segments are different points of views. In the potential segment, we use to define potential of the portfolio. based on his or her location, city-based attributes, and the customer total loan information. We can add more data if the company has or if we can get. The potential segment is hierarchical. So if the competitors of the bank location, city-based deposit ratio, city-based loan ratio, and total amount of taxes increase, then the potential segment value of the portfolio also increases. In the performance segment, we define the similar portfolio performances into clusters. In the KPI segments, we define KPI segments for each KPI groups. The KPI segments are also hierarchical, so we can find out in order where the portfolio is in the segment. We will use these segments in the future at the target optimization phase. Following the segmentation step, now it's time to develop forecasting models.
Hello again, I am Sardar and I'm keep going. In the forecasting component, we are going to develop forecasting models for each portfolios and KPI. Before developing the models, we need to categorize portfolios because each type of needs different types of modeling. At first, we categorize portfolios as regular portfolios, irregular portfolios, and new portfolios. Regular portfolios shows more stable KPI data and suitable for classic forecasting approaches. But irregular portfolios and new portfolios are not suitable for standard forecasting models. So we use different kind of approach like moving average or different kind of parameters to forecast irregular and new portfolios. After categorizing the portfolios in reference of their KPIs, we are going to start develop the models. We want to see performance values of different kind of model approaches. Every model has its own approach and forecasts the data. Some models generate a formula, some models define weights, or some models only use the historical KPI data, and so on. So 6 models will be developing to all portfolios and their KPIs separately. Also, we are not limited with any approach. We can add more specific models to develop forecasting algorithms. So we can increase the model variety if we need different point of views in forecasting phase. All models are challenging with each other after developing the models. The champion models is dynamically selected by the model performance criteria at the end of the challenge. Maybe we can look MAPE or something else. The performance score is calculated by weighted periods of historical period and also holdout period of data. In this slide, you can see the winner line. They are starting the challenge with each other. The models which has the best performance score wins the challenge and assigning as champion model. Here you can see on the example, Sarumax model wins the challenge because it has the best performance score and will be assigned as champion model for this portfolio, specifically this KPI. The champion models are selected for each portfolios and KPIs in the system and used as final forecast separately. So each portfolio and KPI has its own champion models. So you can see the example on this slide. The selected models can be different for each KPIs or for each portfolios and each their KPIs, we can say. We implemented this project to one of the biggest participation bank of Turkey, and we found these performance values shown in the slide. In the training period, with the performance was 96%. Also, on the holdout performance, we got 94% of success. After implementing this project, there was a monitoring period and we reached 95% values, which are very good performance values, we can say. In the third step, there is time to target optimization. In the segmentation step, portfolios are segmented according to their different characteristics, and portfolios with similar characteristics are determined. In the forecasting steps, the KPI values for the future periods are estimated by different kind of modeling algorithms. The forecasting step makes a prediction based on the portfolio and KPI by only its own pattern. But in the optimization step, it is aimed to catch all full potentially of the portfolio based on not only just its own past performance, but also similar portfolio performance values. So we designed this system as a system that lives continuously. The target optimization step is very important step because we use segments actually and forecasted values of portfolios and KPIs to optimize and finalize the targets. First of all, we create blocks based on segments, which Yilmaz mentioned before. Also, we found out and gathered similar portfolios of each KPI. Then we create microsegments in each block to define closed portfolios for building microsegment ladder. This ladder has several hierarchical steps. We use these steps to define the target value of each portfolio. For example, actual value of level 2 is defining as target for level 1. Also, level 3 is defining as target for level 2, and it goes so on. We use this ladder approach because we don't want to give more targets than the portfolio can do. It's time for budget optimization.
And thank you, Serdar. At the end of the target optimization phase, we have all targets based on each portfolio and KPI. If the company wants to balance all target outcomes with the budget, we need to do a budget optimization step. If the total amount of targets below the budget, we need to increase the targets to balance the budget, or vice versa, if the company needs. We use different kind of approach to balance target outcomes with budget. If the budget is above or below the target, we use different formulas for each scenario. After the budget optimization step, now we are ready to go live. And now it's time for the last step, the deployment step. After all segmentation, forecasting, and optimization steps done, business users can add their own know-how and field feedback through customizable management user interfaces. After this cognitive approach, we publish our outputs to the operational systems. The business users have the capability to monitor all the system, portfolio performances for all KPIs, which portfolios are below or which portfolios are above the target. Also, they can monitor modal performances at the time, and modal performance change by different periods. So different kinds of reports can be developed to monitor all of the system. And finally, I pointed out that we designed brand-specific AI-based target management as a continuously living cognitive system. Thank you for listening. If you have any further questions, please contact us through info@aims.com.tr and follow us, our social accounts, as you can see on the slide. If you have any questions, we can answer on Ask a Questions section. And thank you very much for your listening.
Thank you.
Thank you, everyone.
Serdar and Yilmaz. I just want to ask one question from my end. If you had to summarize brand-specific management to maybe like a 5-year-old or something, someone who's a beginner, I would say, how would you explain it to them? Like what is the basic output of that?
The basic output is setting up new targets for each portfolio. For example, the banking portfolios are generating their own KPIs. The bank have set their targets for future months. They need to achieve their targets for the bank.
Let's say
we optimize this target optimization. We use this project as using machine learning and AI algorithms to find out what will be the targets for the portfolios for all KPIs. We use machine learning, AI algorithms, clustering algorithms, spinning and lifting sometimes using formulas to setting up new targets for all portfolios for each KPIs. I can summarize like this.
It's really nice summarization. I really like it. Really exciting solution.
Thank you.
Thank you so much, Serdar and Yilmaz.
Welcome.
We're really happy to have you on board. It's been an amazing, amazing day. And now we have something really nice upcoming for all our viewers here. So we have a networking session, and we are covering around 4 topics here. We are covering your career in data science. If you're starting data science, my colleague Kamer can help you with that. Industry-focused practical uses of AI and ML. I'll be there in that networking session. And ethics in AI, my colleague Naira will be focusing on that, and deep learning, my colleague Anam will be focusing on that. So before we go to the networking session, please do fill up the survey so that we know how we did today. We are so happy that all of you joined us today. We are so excited to even continue doing something like this with our partners, with external speakers. Even you can actually opt in to become an external speaker in this survey link itself. You can scan the barcode or go to the link directly. One of my colleagues will post the link in the chat, or I will post it. And how do you go to the networking session? It's very simple. You can, on the top, you'll see a more button. Click on more, and you're going to see the networking session itself. And from there, you can go ahead and join us there, depending on what you're interested in. We'll be there for 20 minutes, and you can have a chat with us, and we'll be more than happy to answer all your questions. Thank you so much, everyone, for joining us today, and we'll see you in the networking session.